Welcome to the topic task on basic hydraulics. Let's start with the fundamentals. Basically, there are three major parameters of interest when discussing hydraulics in water pumping systems: flow, head, power, or Q, H and P. Flow is measured in cubic meters per hour, head is measured in meters, and power in kilowatt. Flow can be described as the amount of water that a pump transports through the pipes in a given time. That's why it's measured in cubic meters per hour. The head of a pump is the pressure it is able to provide. It describes the height to which it is able to elevate water, which is why it's measured in meters. In other words, a head of 40 meter means that the pump is able to lift water 40 meters in the air through a vertical pipe. The head is split into suction lift and elevation lift, which may be converted to pressure. But not all the pressure is available. Some of it is lost due to friction in the piping system. Power, P, in a water pumping system can be described as the force and speed by which the water is transported, and it is directly dependent on both flow, Q, and head, H. Power is measured in kilowatt, kW. The interaction between flow, head, and power can be described as P equals Q times H times C, where C is a constant depending on the pump efficiency, gravity, and fluid type. If you double the flow or the head, the power will also double. If you double both, the energy will quadruple. Transporting fluids in water pumping systems creates friction between the fluid and the surfaces it touches. This leads to loss of energy and pressure and is what we refer to as friction loss. Friction loss occurs all through the system, in the pipe itself, the elbows, and the valves. The level of friction loss is dependent on the flow in the system and the viscosity of the fluid, as well as the length and surface of the pipes. Friction loss also depends on the fluid velocity, the speed at which the water is pumped. The fluid velocity, V, can be calculated as V equals QA times C, where Q is the flow, A is the cross-sectional area of the pipe, and C is a constant to convert the velocity to meters per second. The more water you pump and the faster you do it, the higher your friction loss. To minimize fluid velocity and thereby friction loss, you have two main options: reduce flow or increase the pipe diameter. Increasing the pipe diameter will also increase the initial cost of a pumping system, but in the long run, the total life cycle costs will be substantially lower as the larger pipes will minimize friction loss and boost overall pumping efficiency. Vapor pressure is an important issue when working with pumping systems. It describes the exact pressure and temperature at which water turns from water into vapor. At normal atmospheric pressure, water boils at 100 degrees Celsius, but if the pressure in the pumping system drops below a certain level, the water will start to boil. As soon as the pressure increases again, the vapor turns back into water. This is called cavitation, and that is very damaging for the pump. So what is cavitation exactly? Well, cavitation can be defined as the rapid formation and collapse of air bubbles in the water. It occurs near the impeller inlet, where the pressure may be reduced below the boiling point of the water. When the water boils, it turns into vapor, but when the pressure rises beyond the boiling point once again, the vaporized water molecules implode and return to their liquid form. These implosions can be heard as a loud noise from the pump and may result in pitting of the impeller and the pump housing. Cavitation can be avoided by lowering the pump inlet and increasing the inlet pressure, reducing friction loss in the suction pipe, reducing the flow of the pump, or increasing the elevation of the suction water level. This concludes the presentation on basic hydraulics. You are now ready to test your knowledge and complete the task. Thanks for your participation.